Good afternoon, friends. This is Mahadev here. At Spectralite, we make biocomposites using crop waste and fast renewable materials. For us, fast renewable is anything that can be renewed in a period of 3 years cycle. So we work on pretty much crop waste coming from farm, forest, or the factories. That includes rices, coffees, bamboo fibers, barley waste, and various other agricultural waste, including wood as well. We make biocomposites, which includes both biodegradable and recyclable biocomposites. And then we help companies to use those materials into various industrial and consumer products. We've also developed blockchain-based technology, which helps to manage the stewardship of resources. So customers can now view where we source the raw material from, where we manufacture the biocomposites and the finished products. That way, that builds a credibility and trust in the system and accountability across the stakeholders. We've also recently developed artificial intelligence system to formulate biocomposite matrix based on various customer requirements. What we've understood in the last 7 years of doing research and development is that no single requirement can be met with one particular formulation. So every customer, every product has its own unique specification and need, and that would require us to formulate materials which are specific to their application. So instead of us having hundreds and thousands of formulation that we have to refer to back and forth for every customers, we built an artificial intelligence system that would recommend the right formulation for the customers to going forward. A few applications that I would like to talk about. First being automotive. Every car today has more than 100 kgs of plastic in them. If you look at WPC or natural fiber composite or any lignocellulosic composite materials, there are two types, thermoplastic and thermoset. For all of my discussion today, we'll be only referring to thermoplastic biocomposites or natural fiber composites. So in automotives, more than 100 kgs of plastics are used. They are intended to reduce the weight of the car, provide better passenger safety. But with more and more increased use of plastic, there is also concern about increased carbon footprint and reduction of fossil resources. So using wood plastic or natural fiber composite was a fantastic alternative, because on an ecological front, we are able to reduce the consumption of plastic. We are able to reduce the carbon footprint of the material that goes into making the car. Because of better strength and stiffness properties, some of the components, we were also able to reduce the weight of the component, which means the cars can now run longer with lighter parts than the plastics also. It has created a fantastic economical value proposition as well, because by adding crop waste or wood waste into plastic, we are able to create wealth out of waste. And in some cases, we are also able to reduce the target price of the components, which makes it attractive for customers as well. The social impact of doing this is that it helps in community development, especially because some of these crop waste and agricultural or wood waste can create value for rural economies, usually farmers, and that can create in better community development as well. As an example, we have implemented Parcel Shell for Renault Nissan Group. Here we were able to demonstrate weight reduction of the component. We were able to also reduce the cost of the component, and the carbon footprint was significantly reduced as well. So here we used bamboo fibers after benchmarking against various other natural fibers that were available for this component. We're also in discussion with a number of other customers who are doing the evaluation. Unfortunately, the COVID delays hasn't fruitified some of those developments, but there is increased interest in the automotive, whether it is combustion engine or electric engine vehicles, to implement some of these sustainable materials. Looking at the construction space, wood is one of the fantastic resources to use in the construction space. No doubt, I think it's one of the best use of wood, because it helps to sequester carbon in the housing and construction infrastructure for many, many years. So for us, from a sustainability standpoint, using wood for housing and construction is a fantastic opportunity. However, we also see that in addition to wood, WPC or wood polymer composite plays an important role in certain areas, especially where it requires a certain treatment. As an example, recently we constructed our office, and we had a choice to use WPC based doors versus the wooden based doors. And I mean, out of interest, I tried both options in the office. I could just realize how seamless it was to just get a high quality wood polymer composite doors at a very reasonable price, and it was all installed and done in 2 days time. Whereas getting a wooden door, an equivalent wooden door, was quite laborious. It finally, although the plywoods were cheap, the final cost of landed cost of making a nice, good looking wooden doors was at least 2 times the cost of actually WPC doors. The lead time, at least 3 weeks to get the wood finished and treated and polished and processed. Without these treatments, they don't last long. So in a sense, some of these components where it requires not just the plywood as it is, it becomes economical and also better to use wood polymer composites. So my experience as a user of wood polymer composite for my own application, I found that the WPC doors are fantastic, and they have all the other benefits like moisture resistance, termite resistance, and so on and so forth, basically. And if incorporated, it also comes with fantastic flame retardancy as well. There are many applications where, and this is one of the main sectors where WPC is used. China is one of the leaders with more than $35 billion of WPC application into construction industry. India has some space. There are some manufacturers who work on the WPC extrusion for construction and housing space. The next one is material handling. You will see that in order for the economy to run and the goods to move from one location to another location, transportation is extremely important. These pallets are quite often used to move goods. It becomes extremely easy to handle materials while they are being shifted from within the truck and across the trucks, between truck and the ship, and across borders. So the pallets are a very huge economy. In US alone, it is estimated that 1/4 of their forestry is used for making wooden pallets. So there is a huge outcry to reduce use of wooden pallets. Many of these wooden pallets are one-time use, and there is an emerging space of plastic pallets coming in, where they are much more durable. They have long shelf life, and they also come with a very high load carrying capacity as well. So in looking at WPC, they come with advantages of both wooden pallets and plastic, because instead of going all with plastic pallets, which has a high carbon footprint, by going with wooden pallets, we can even offer some carbon neutral solutions, which has same durability as plastics do, but then they don't cut trees or forest in the process because they use agricultural waste or wood waste stream. There is space in the disposable space that we're looking at. If you look at these wooden spoons, forks, and knives, they all look fantastic, fancy, and sustainable. But we ourselves have tested at IWST and found that most of them are treated with either formaldehyde or boric acid. That means clearly, while they are visibly sustainable, they are actually hazardous for human consumption, human use. These solutions are better avoided. Instead of having plastics, we are now working on 100% bio-based and compostable cutleries. That would be a blend of starch and thermoplastic starch and either bamboo, rice husk, or wood stream. So these are already tested safe as per food contact standards in India, up to about 75 degrees centigrade. So it pretty much solves most of the applications. In fact, last year when we participated at the Karnataka Startup event, we won amongst the 900 participants, and the Karnataka government is actually sponsoring the development of spoons and forks for the market. So we're almost on the verge of completing them. In fact, I have some samples here that I can show, which we've just from the molds that we have actually developed. So this is something that will be launched very soon after the lockdown. This is again a result of the development that we've done jointly with IWST in Bangalore. The next one is household applications. In household applications, we are seeing that while wood is fantastic for furniture because its shelf life is long, but in terms of other serveware, foodware, food contact applications may not be the ideal solution because I mean anything that comes in contact with wood or natural fibers without it being treated would be hazardous and would leach into the food also. So we've got a number of applications that has already commercialized as well across household products, which are both retailed on platforms like Amazon, Flipkart. We also have our own brand iha.eco where we've launched these household products. With that, I'd like to conclude, but then just to also summarize, a number of discussions that we are having with companies includes in packaging, cosmetics good packaging, consumer good packaging, rigid and semi-flexible applications. In terms of other consumer goods, which are men's grooming products or women grooming products, which are usually made out of plastic. Then there is gardenware products. So there are a number of applications that we are working with different customers. It is just that we are hoping that the lockdown situation and corona situation would get better for some of these to finally get commercialized and you can see them in the market. So with this, I'd like to conclude. It's a fantastic solution. No doubt there are challenges in implementing. I'm keeping this discussion short and not discussing the challenges aspect, but there is a great potential with this material and look forward to continuing working on this. Thank you so much.